In this video, we're going to continue to look at functions, whereas in the previous video, we were looking at function in terms of your ordered pairs. Now we're going to look at identifying a function as an equation. So I want to look at a couple examples here. If we have the following equation, such as x squared plus y equals 10, we want to determine, does this equation represent a function? In other words, does it meet all of those characteristics we talked about before? And one of the main ones we want to look at is, do we have repeated x values? So in other words, do we have an x value that gives us the paired with two different y values? So if you think of an equation here, we know that we have our x and y. So do we have repeated x values for y values based on this equation? The easiest way to determine this is to solve your equation for y. So if we solve for y, we move over the x squared, so we get y equals negative x squared plus 10. Now, if we notice what we're really looking at, do we have repeated values? Well, and we can kind of make a chart here and say, well, if we pick a value for x, such as a -1. If we plug a -1 in, we square it, we get 1. And then the negative out front makes it negative, so we have a -1 plus 10, which would be equal to 9. So are there any values that if we plug a value in for x, are we only going to get out one y value? And in this case, that's all that we're going to get out. So here, we certainly do have a function. Okay, so in other words, this equation represents a function. So if we're to plug in values for x, we're going to get out one and only one y value. So that's really what we're looking for when we have an equation. Do we end up with repeated x values here? So if we look at another example, what if we have something like x plus y squared equals 10? Now, are we going to have repeated x values? Well, once again, if we solve for y, we would have y squared equals, if we subtract this, we get 10 minus x. Now, to get rid of the square, we have to take the square root of both sides. So if we take the square root of both sides and realize we're going to end up with y equals the square root of 10 minus x. But when we take the square root, remember, we have to put in plus or minus, because it could be plus or minus. And if you forget that, think of the example over here. If we have, excuse me, y squared equals 9, then we know that that means y could equal to plus or minus the square root of 9, because y could be a positive or -3, because 3 squared is 9 and -3 squared is 9. So over here, we have to put in plus or minus the square root of 10 minus x. So what does that tell us? Well, that really tells us that we're going to end up with one x value is going to give us two y values, one positive and one negative. For an example, if we let x equal 6, if I was to let x equal 6, 10 minus 6 is 4, square root of 4 is 2. So we'd have a positive 2. Well, the other option is if 10 minus 6 is 4, we also get the square root of 4, but now we also have a negative, so 6 is 2, or 6 and -2. So here you have your repeated x values, and it's because of this plus or minus. So I'm just showing you here in green that 6, 2 and 6, -2 gives you repeated x values. The plus or minus in front of the square root really tells us that, so therefore this is not a function. Okay, now if you notice with the equation above, it's okay that we have an x squared, but down here we have a y squared. It's not okay to have a y squared, because when we take the solving for y, we have to take the square root, which is going to give you a positive and negative. So kind of a shortcut here is if you happen to see your equation contains a y squared, then you know it's not going to be a function, because as you solve for y, you'll eventually have to take the square root where we need to include plus or minus. All right, we have another example here. Let's say that we have x minus 2 the whole quantity squared plus y squared equals 4. Now, does this equation represent a function? And I guess specifically I should say, does it represent y as a function of x? And based on what I just stated, you probably are saying, well, we have a y squared, so no, this is not a function. And you would be correct. And the reason we know this is not a function is you're going to end up with that repeated x value. And if we solve for y, we would have y squared equals 4 minus x minus 2 squared. And then, of course, at this point, we would need to take the square root. So y is equal to plus or minus the square root of 4 minus x minus 2 squared. And because of the plus or minus again, this equation is not a function of x. All right, if we look at another example, what if I give you the equation y equals the square root of x plus 5? Does this equation represent y as a function of x? Now, I'll give you a minute to think about this and see if you can come up with the answer. You may want to pause the video and think about it for a little bit. Now, you're probably looking at this, and a lot of people make a mistake here and say, well, wait a second, we have a square root, so that should be plus or minus. Well, notice here, we didn't take the square root. The square root was already in the equation. So because the square root's already here, it's just going to be whatever sign they have. So here, they're indicating this is a positive square root because they do not have a negative here. So here, this is actually a function. Okay, so be careful with this example. A lot of people get hung up and see the square root and think, oh, well, this is not a function because of the square root. Well, the square root is already there, so it is a function. The reason the example is up here above, notice the original equation, x plus y squared equals 10. There's no square root in the problem. We actually put the square root in the problem, and that's why we have to put in the plus or minus. All right, if we have another example here, we have one with an absolute value. We have the absolute value of y equals 4 minus x. What do you think here? Does this represent y as a function of x? And if you think about how you solve absolute value equations, you could probably figure this out, or you could always just make a chart, or you could pick some numbers. For example, if we made our little XY chart, we could pick values and find out what are the possibilities. Well, if I was to pick, for example, if x is 1, you get 4 minus 1, which is 3. But because of the absolute value over here, and maybe it's better to say instead of picking x equals 1, what if I let y equal 3? If I was to let y equal 3, then the absolute value of 3 is equal to 4 minus x. Well, the absolute value of 3 is 3, so 3 equals 4 minus x. So if I move the x over, we get x plus 3 equals 4. Subtract the 3, so x equals 4 minus 3 is 1. Well, the other possibility is, what if I let y equal a negative 3? Well, the absolute value of a negative 3 equals 4 minus x. Well, the absolute value of a negative 3 is 3, so we again get 3 equals 4 minus x. And of course, as we solve this, we're going to end up with the same answer, x equals 1. So once again here, we have one x value matched up with two different y values. So here you have these repeated x values, so this is not a function. Okay, and you could actually figure this out with how you would solve an equation. If you think about how you solve the absolute value of equation, you would have absolute value of y equals 4 minus x. Well, the way we solve an equation here is we take we can think of this as y equals 4 minus x. And because y could be negative, we say y could be equal to the negative of 4 minus x. So if you notice here, you end up with two y values. So you have one x value is giving you two different y values, so therefore it is not a function. All right, I have one more example to look at for this video. And the equation is x minus 1 equals 0. Does this represent y as a function of x? And this one we could probably easily tell from making a chart. And this one, hopefully you could shout out the correct answer. Well, if we solve the equation here for x, we get x equals 1. Add 1 to both sides, so x equals 1. So that tells us x is always going to be 1, so y could be any value. So once again, if you notice, there's no y variable in the equation, so that means y could be 0. If y is 0, x is still 1. Well, if y is negative 3, x is still 1. If y is positive 5, x is still 1. And if we think about the graph of x equals 1, that means we're going to go to 1 on the x-axis, and we would have a vertical line. So if you notice here, x is always 1 no matter what value we have for y. So this completely defeats the definition of a function, so this is definitely not a function. Because in this example, x equals 1, the 1 is being paired up with everything. So it's not only repeated once, it's repeated for the whole equation. So the easiest way, if you have an equation, to identify whether you have a function or not is you can simply look at solving for y and see if you end up with two different y values for one particular x value.